given z equal to x into f of y plus y into g of x. Consider as equation number 1. Now let's partially differentiate it with respect to x. Just apply dou by dou x on both sides of the equation, okay? Partially differentiating one with respect to x. Just apply dou by dou x on both sides of 1. This gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we will treat y as constant. Here f of y is treated as constant, y is treated as constant, okay? So partial derivative of x with respect to x is 1, but into constant plus constant into dou by dou x of g of x. Since we know that dou z by dou x can be replaced by the notation p, you will get p equal to partial derivative of x with respect to x is 1 into f of y plus y into partial derivative of g of x with respect to x is g dash of, g of x with respect to x is g dash of x, right? This gives us p equal to f of y plus y into g dash of x. Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Now partially differentiating 1 with respect to y. This is our equation number 1. Now let's partially differentiate equation 1 with respect to y. Just apply dou by dou y on both sides of the equation. Here we are partially differentiating with respect to y, so we will treat x as constant. This gives us dou z by dou y equal to x into partial derivative of f of y with respect to y is f dash of y plus partial derivative of g of x into partial derivative of y with respect to y is 1. Since we know that dou z by dou y equal to q, right? Just replace it by q. Q equal to x into f dash of y plus 1 into g of x is g of x. Okay. Consider as equation number 3. See, equation number 2 involves p, equation number 3 involves q. Now let's find equation involving r. We know that r is nothing but dou square z by dou x square, or we can write this as dou by dou x of dou z by dou x. Dou z by dou x is nothing but p, which gives us dou p by dou x. So dou p by dou x is nothing but r, right? Now pick equation involving p and partially differentiate it with respect to x so that you'll get the equation involving r. Okay? What we are going to do now, we are partially differentiate 2 with respect to x. Now let's partially differentiate. With respect to x. Just apply dou by dou x on both sides of 2. Here p is nothing but dou z by dou x, or partial derivative of p with respect to x is itself r. R equal to, here we are partially differentiating with respect to x, so treat f of y and y are as constants. So partial derivative of a constant with respect to x is 0 plus constant into partial derivative of g dash is g double dash. This gives us r equal to y into g double dash of x. Consider as equation number 4. Okay. Good. Now let's find equation involving t. T is nothing but dou square z by dou y square. Or we can write this as dou by dou y of dou z by dou y. Dou z by dou y is nothing but q. So dou q by dou y is nothing but t. Right? Now let's partially differentiate equation involving equation involving q with respect to y, so that we'll get equation involving t. Now what we are going to do, we are going to partially differentiate this 3 with respect to y. Just apply dou by dou y on both sides of 3. Here we are partially differentiating with respect to y, so we'll treat x as constant. This gives us dou q by dou y, which is t. So x into constant, x into partial derivative of f dash with respect to y is f double dash of y, plus partial derivative of g of x with respect to y is 0. Since g of x is treated as constant, x is also treated as constant. Okay, this gives us dou q by dou y is nothing but t, right? So we'll get t equal to x into f double dash of y. Consider as equation number 5. We observe these equations, we have f g dash, f dash g, g double dash, f double dash. So these equations are not enough to find the required partial differential equation. So we'll go for s also. S is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x, right? Since dou z by dou y is nothing but q, so dou q by dou x is s, or you can say, yeah, it's replaced by p. Dou p by dou y is also s. Okay, so if you want to find equation involving s, you can pick equation involving q or equation involving p. If you want to pick equation involving p to find equation involving s, you can just partially differentiate it with respect to y, or if you want to use equation involving q, you can just partially differentiate this equation with respect to x. So we can go for this or this. Okay, I'm going to try with equation involving q. We have 3 q equal to x into f dash of y plus g of x. Now I'll partially differentiate with respect to x. So dou q by dou x is s equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. So f dash of y is treated as constant into partial derivative of x with respect to x plus partial derivative of g of x with respect to x is g dash of x. This gives us s equal to f dash of y into partial derivative of x with respect to x is 1 plus g dash of x. From this we'll get f dash of y plus g dash of x. Consider as equation number 6. S equal to f dash of y plus g dash of x. Right? Now observe these equations. In S you have f dash and g dash, right? If you have the values of f dash and g dash, just put it in the equation. Then you'll get the required partial differential equation. So now we need to find the values of f dash and g dash. Okay, so can we find the values of f dash and g dash? Is it possible? Let's see that. We have to do trial and error method. Okay, right now we have equation 2, right? We have 2, that is p equal to f of y plus y into g dash of x, right? Or we can write this as f of y plus y into g dash of x equal to p, right? Now take this term to RHS, you'll get y into g dash of x equal to p minus f of y. Now divide both sides of the equation with this y, or just take this y to RHS, you'll get g dash of x equal to p minus f of y by y, right? So you got the value of g dash of x, which is p minus f of y by y. We got this using equation 2, right? Now let's find the value of f dash of y using equation 3. We have equation 3, that is q equal to x into f dash of y plus g of x, right? Now you can write this as x into f dash of y plus g of x equal to q. Now take this term to RHS, you will get x into f dash of y equal to q minus g of x. Now divide both sides of the equation with this x, or just take this to RHS, you will get f dash of y equal to q minus g of x by x, right? So you got the value of f dash of y using equation 3, which is q minus g of x by x, right? By 3, right? Now we got the values of g dash of x and f dash of y. Let's put it in equation 6 and see whether we are going to get partial differential equation or not. We have equation 6 as equal to f dash of y plus g dash of x. Substitute the values of it, since f dash of y equal to q minus g of x by x and g dash of x equal to p minus f of y by y, then this becomes s equal to q minus g of x by x plus p minus f of y by y, right? Take the LCM of x and y, you'll get xy. In the numerator you'll get y times the numerator of first term plus x times numerator of second term. This gives us yq minus y into g of x plus xp minus x into f of y by xy, right? Now multiply both sides of the equation with xy, or just bring this to LHS, you'll get sxy equal to px plus qi. Take minus common from these two terms, you'll get minus of y into g of x plus x into f of y, or we can write this as x into f of y plus y into g of x, which is a given equation which can be replaced by z. Sxy equal to px plus qy minus of x into f of y plus y into g of x, right? Which gives us sxy equal to px plus qy minus z, since z equal to x into f of y plus y into g of x. Or you can write the same equation as, bring this minus z to LHS, take this to RHS, you'll get z equal to px plus qy minus sxy. We'll just write the terms involving p, q, s in one side, and the terms that does not involve second derivatives in one side, okay? The other side, you can say. So this is the required partial differential equation, or we can just write this as px plus qy minus sxy equal to z. Okay, the terms involving second derivatives are in the LHS part, and the terms that does not involve any second derivative is in the RHS part. Okay, therefore px plus qy minus sxy equal to z is the required partial differential equation. This completes the problem.